So let's go with starting with the dependence and independent variables. Okay. Uh, think about the temperature. Once the temperature is going high, it's getting very hot, for sure you are looking to go for beach, right? Yes. So some people going to the beach. Let's go and see how to uh, plot the relation between the temperature degree, which will be independent because this is the one it's changeable, and depend on that how many people going to the beach, right? So the independent will be the temperature because it's changed, right? And the response for this one will be more people going to the beach. Okay. So this is what we call a scattered plot. So most of time you scattered the independent variable, right? With the temperature for sure in Fahrenheit. Okay. If it is in Celsius, it will be a big problem, right? So the independent, the changeable one, in the independent variable, it is the temperature. Once the temperature increasing, right? More people going to the beach, right? So if you're counting how many visitors come to the beach and link it to the changing in the temperature, yes, you will find increasing on the temperature, increasing the number of visiting the beach. Okay, this is what we call it scattered plot. So how to scatter this one? For sure, you have the independent variable here, whatever it is, and y is here. And you have these values, right? And you scattered x in this one up to the scale of the values of x, and scatter the y in the vertical axis, right? And you have the points. These points, we call it scattered plot, okay? If you have weight versus the exercise, for sure, more weight, less exercise, right? So it will be opposite to this one. If the weight increasing, less exercise doing, right? So this is what we call it positive relation, linear relation, sorry, linear relation. Okay. Positive linear relation. Roughly, because we are going roughly into a line, right? Okay. So here we have positive linear relation, but in this one we have negative linear relation, negative. So negative when you are going down from left to right, and positive when you're going up when you go from the left to right. Okay. Sometimes you have two variables, but none of them depend on the other one, right? Like the box read versus the shoe size. There is no link, right? So here, there is no linear relation. You cannot find the line here, right? Okay. Now we know what does it mean scattered plot. We'll go in more details when we go in this one, right? For sure here, we cannot find any track to follow, linear or non-linear, right? Here, there is slightly going up like a line. Here, higher. Here, perfect. Why it's perfect? Because we can draw a line passing through the whole values of x and y, the independent and the dependent, right? Okay. So here, when you go up, you have a positive, right? When you go down, you have a negative. Sometimes you have non-linear, you have curved one, right? You have a curved one. And sometimes partially line. Yeah, it's very weak linear regression. Okay. How you said low, high, perfect. Perfect is very clear, but the high depends on your point of view, right? Okay. But we agree about positive and negative because we're going up or down. But about low, high, maybe moderate, we have to measure this one. How to measure this one? We measure it by the correlation coefficient R, right? So this correlation coefficient has a value between +1 into -1. So your R between bigger than or equal to -1 and less than or equal to 1. So may you have 0, R is 0. It means no linear relation. No linear relation. Okay, fine. Now, for up to 0.5, you call it weak. Okay, you call it what? Weak. If you go further, more than 0.5 up to 0.7, some boxes make it 0.75, but we'll go for our box 0.7. This case we call it moderate. Okay, but if you exceed the 0.7 up to 0.999, you call it strong. If you reach exactly 1, positive 1, you said perfect positive. Perfect positive. Okay, let's go to the opposite side. If we go to the negative side, if you have exactly -1, so you said negative perfect. Negative perfect. Okay. Now, if you have 0.5 from 0 to -0.5, yes, you have negative weak. Okay. From -0.5 to -0.7, you call it negative moderate. Okay. If you exceed 0.7 to 0.99, but negative, you said negative strong linear relation. If you are exactly -1, it will be perfect. Here, this is the one perfect. No points outside your line, okay? But here, because you can say low, because too many, if you have a line, you have too many points outside the line, your line, okay? But high here, because if I make a line, slightly they are very close to the line, and the number of points down the line exactly equal to the number of points above the line. So it's okay, quite high. So it is better to measure the strength of the linear relation using the correlation coefficient R. Remember, R value between -1 and +1. Okay, this is the calculator can calculate this one for you. Don't worry, I will show you how to use it. Now, from the correlation coefficient, if you square the correlation coefficient, you will get something called, yes, coefficient of determination. Coefficient of determination. So the coefficient of determination is the square for the correlation coefficient R, right? Okay, it is always decimal, but because R between -1 and +1, and we are going to square this one, so this one is always positive, always positive. And between 0 to 1, because when you square any negative, it will be positive, right? So remember, R between -1 and +1, but when we square R, we have something called the correlation of determination. Okay, so between 0 and 1. Say you have 0.842 when you square your R, right? So it is better to change this one into percentage by multiplying by 100. So you have 84.2%. What is the meaning of this percentage? What is the explanation for the coefficient of determination? This percent, a change in your dependent variable, the one you response, change in your dependent variable y, results by x, results by the change of x, results by the change in x. Okay, maybe the rest of this 100% does not depend on x. Yes, this is what we call it the coefficient of non-determination. So the coefficient of non-determination is 1 minus r squared, and also always positive, and also between 0 and minus 1 and positive 1, right? So the coefficient of determination is r squared positive. Also, the coefficient of non-determination is always positive because 1 minus r squared. Okay. As I said, the coefficient of determination is the percentage of a change in the dependent variable results or occurs by the change in x. And because the non-determination is 1 minus the coefficient of determination, it means I have 1 minus r squared. If I multiply by 100, I will get a percentage here, which is the complement of the percentage of this one, which is, I think, 15.8, if I'm correct. So this percentage of a change in your dependent variable y does not result by the change in x, right? Okay. So if you are given the coefficient of determination, 1 minus the coefficient of determination, if it is in decimal, give you the coefficient of non-determination. If it is given in percentage, 100 minus the percentage of the coefficient of determination, give you the non-determination coefficient. Gotcha? What's left? The left, how to find the line equation, the best line equation, which we call it the linear regression equation. So the linear regression equation is the best line represent the relation, the linear relation between the independent variable x and y, right? Okay. Mostly we write it y equal to a plus bx as it in your calculator. In your calculator, it's written like this, right? Okay. So whatever in front of x with the sign, we call it the slope. We call it what? The slope. So for b value, you don't care about the value itself. You are caring about the sign of b, the sign of the sign of b, right? The sign of b. Why? Because if the sign of b is positive, it will be positive linear relation, right? If the sign of b is negative, it will be negative linear relation. You don't care it is 150 or what. No, you are caring about the sign of your slope. Okay? Because if the slope is positive, you are going up. If the slope is negative, you are going down. Okay? Now, what about this one, A? A, we call it the y-intercept. The part and cut it from the y-axis. Okay? So if you have such a line, this exactly here is the value of A. So this is a y-intercept. So what does it mean, y-intercept? It means at x equal to 0, your y will equal to A. Okay? What is the point of having the linear regression equation? To have the prediction, to find or to predict any value for the prediction for y if x is known, is given. Or you would like to know what is the response up to this action or this change in the independent variable, right? So what you are going to do, you get this value, plug it in the equation or substitute in the equation, you will find the value of y, right? So if x is 0, none happen, so y will equal to the y-intercept A, right? And also, I can measure the change in X if we change the response change up to the change in the independent variable X. So if X exceed by 100 or 10 or 1 or whatever, what is the value of Y happen? So I can put the value X equal to 0 and X equal to 10, and I see the difference of Y when X change from by 10, right? So I can find X equal to 1 and X equal to 11. The same, because the change from 1 to 11 is 10, okay? So this is the use of linear regression equation, right? The main point of the linear regression equation is the slope B. What is the link between the correlation coefficient R, correlation coefficient, and your linear regression? R is positive, B must be positive. If R negative, B is negative. So what is the difference? This is just indication for the relation, positive or negative indication for the relation. This one, indication and strength. They give you the strength of your linear relation. Strength of your linear relation. Okay, so B positive, R positive, B negative, R negative, right? But the difference, we said, R from -1 to -1, telling you if it is 0, no linear relation. If it is up to 0.5, you have positive weak. From 0.7, you have positive moderate. To 0.99, you have positive strong. If it is exactly positive 1, it will be perfect positive. You can do the same in the negative side, okay? So you just replace the positive by negative, okay? Now we have done everything. Let's go and see how to use your calculator to do this one, right? Okay. I'll go to my YouTube channel to show you this very short video. I'm not sure you will hear the voice, the sound or not, but you can follow my steps using your calculator, right? Now, how to use your calculator to find the linear regression equation, y equal to a plus bx. Press mode, go for stat, number 3. Go for a plus bx, number 2. Now you have 2 columns, right? X and Y. Sometimes you have frequency column, you can deactivate it by shift and mode and go down for stat number 4 and make the frequency off. Now I am inputting the values for X, 1, the first one 72, and press equal, and then the next one press equal, the third one. Okay. Now after I finish X, I go using this key, the round one, to go up to the first row. I start input my independent variable Y. Yeah, 62. Press equal. 42. Press equal. 19. Press equal. 26. Press equal. 51. Press equal. 62. Press equal. 50. Press equal. 30. Press equal. 15. Press equal. After I finish, I press the button AC and then shift and 1. I am going to use the reg. Reg is the regression, the abbreviation of the regression. Press number 5, regression, or whatever the number you have in your calculator, right? So I'm going to press number 5, regression, in my calculator. You have everything in the CLO2. You have R, the correlation coefficient. You have A, the y-intercept. You have B, the slope. So if I need A, I press number 1. It gives me minus 31.46. Now, shift and 1 again. No need to input your data again. Shift and 1 again, and press 2, which is B, and press equal. After this one, yes, you get B, positive. Yes. Okay. I don't care about the value of B. I'm caring about it is positive, so it means there is a positive relation, right? 1.357. Now the R, shift and 1 and go for number 3, which is R, right? I'm telling you, between 0 and 0.5, weak. If it is positive, it will be weak positive. Up to 0.7, it will be from 0.5 to 0.7 will be moderate positive, and from 0.7 to 0.99 will be strong positive. If it is +1, will be perfect. If you go to the negative side, up to minus 0.5, weak negative, up to minus 0.7 will be moderate, up to minus 0.99, it will be strong. -1, it will be perfect negative. Yes. Now to find R, shift and 1, R number 3. Okay, press equal. R should be between -1 and +1. Yes, R, I have it positive 0.7, which agree with the sign for B, right? Now, what is the relation now? It is exceed 0.7 positive, so it will be strong positive relation, right? Look at this one. B has the same sign as R, right? Positive, positive. But the strength is measured by R, the correlation coefficient. And again, the correlation coefficient value between -1 and +1. Now, I think everything can be done using the calculator. Okay. To find the correlation, the coefficient of determination, you just square R, right? To find or multiply it by 100 if you would like to have it as a percentage, right? To find the 1 minus R squared, which is a non-determination coefficient. If you would like to have it as a percentage, multiply by 100, and you know what is the meaning of each one of this, right? Now, I have a little competition for you if you would like to join me, right? This is why I like students to practice. What is the correct answer here, guys? I told you the independent variable, the one responds to your action, right? The one you measure. So the right answer should be what?
C.
Thank you. C, the response of the variable, the independent, the one we change, right? I thought it is, I'm talking about the dependent. So I'm right. So the one you change, or the scientists change, like when you go to the lab and you would like to see the relation between the current and the resistance, you change the resistance, right? You don't change. Now, if I ask you, this is positive relation or negative relation, guys? Whatever in your mind, just say it. If it is correct, keep it. If it is wrong, we can correct it. Is it positive relation or negative relation? You're going up or down? You're going up.
Positive.
Positive, excellent. Now, we agree it is positive, right? If I'm asking you, which one is the correct answer here? I know the positive relation, they are going to having the same approach. If they are increasing, they will increase together. If they're decreasing, will be decreased together, right? If they are higher, it will be higher together. If they are shorter, it will be shorter together. So the right answer is? In B, you have higher, lower. No, it is not working. And in C, you have lower and higher. It's not working. In D, you have, there is no clear. No, it was clear. It's going to be linear. So I reject B, C, D. So the only one agree with my positive to have the same approach. So they being higher at the years since, right, is higher, right? So when you have a positive relation, you choose the correct answer which having the same approach, higher, higher, lower, lower, right? But we will go for the next one. Okay. This is positive or negative?
Negative.
Excellent. So in the negative, we choose the correct statement about the negative when one is opposite to the other one. So which one is the right answer?
A.
Okay, let's go and check. Yes, correct. Why you choose B? Because this is negative relation, so one opposite to the other one. So you have higher and lower, right? Okay. Can you see any relation here, positive or negative? Can you see any trend? Linear, non-linear?
No.
No relation.
Excellent. So the correct one in this way is a big mess over there. So there is no relation.
B.
Perfect. Perfect. Now let's back to the dependent variable here. Which one is the dependent variable? We know the one change is the independent, right? So we reject B. The one that is constant, no, we reject it because we have to have change in this one. So we reject B and D. If we go for C, the one manipulated variable, no. So we will go for what? The one we measured. Sorry about that. So the one we measured, it being measured is the response. So it's the dependent variable, right? Let's go for this one. You have a study was done, check if the different type of soft drink effect on what? On the blood pressure. The one is affected should be the dependent one, right? The one affect should be the independent one, right? So the correct answer is the dependent, the one respond to the action, right? The one is affected by the independent one. So the blood pressure, because also the blood pressure, the one you measure, right? Okay. Now, you have an experiment making the tightness of the coil make the motor run faster. It means he's talking about the speed here, right? Okay. So you have two variables. Which one affecting the other one to be, which one is affected by the other one, or which one you can measure? For sure, the motor run faster, which means the speed of your motor, right, will be the dependent one. Okay. Now, if you check this one, this is negative or positive linear relation between the heart rate and the life expectancy in years. Positive or negative?
Negative.
Excellent. So if we have such one and we would like to choose a correct answer, we are going to the one opposite to the other one because we have negative. Which one which should be the correct one? So when you go there, you're exceeding higher heart rate, it will be low life expectancy, right?
Yes.
Or shorter life expectancy, right? So the right answer is yes, shorter life expectancy. When you increase the heart rate increased, the life expectancy will be shorter. Okay. Now, about the correlation coefficient values, we know the correlation coefficient R values. Which one is correct for this one? The value of the correlation coefficient R is what? Is it
D.
always positive? D, yes, between minus R and 1 and the positive one. Excellent. Now, the coefficient of determination. Do you know what does it mean, coefficient of determination? It is R squared, right? Okay. He's asking you to find the coefficient of non-determination. He gave it to you in decimal, right? So this is R squared, and we know this one is 1 minus R squared. So you already have r square. So to find this one, you said 1 minus r square is here, 0.72. So the right answer should be what?
C.
Why C? When you subtract 1 minus r square, because he doesn't give you the coefficient, correlation coefficient, he gives you the coefficient of determination, r square. So this is r square, not r, right? And the non-determination 1 minus r square. So 1 minus, this is r square because it is the coefficient of determination. So how much is it? 1 minus 0.72?
A.
Yes, A.
0.72.
0.28. Thank you. Do you have your calculator? Let's go.
Yes.
And how to find the coefficient of correlation? The correlation coefficient is R. Yes, we just watched the video right now and saying, go for your calculator and press mode. Number 3 stat, if it is number 3 in your calculator, go for A plus BX. Please do it with me. It will open 2 columns for you, X and Y. If you have another column called frequency, you can delete this one. How to delete this one? Yes, I can delete this one by shift mode. Go for down to stat number 4, or sometimes number 3 in some calculator, right? You will have windows saying frequency on number 1 and off number 2. We would like off, so you press 2, right? So now this one will disappear, right? I'm saying that because I noticed some students having this problem, right? Because in CL01, we activate the frequency and we forget to deactivate it, right? Good. Now, what is the coefficient of correlation? R.
D.
After you finish, input your data, press AC, as we said, shift 1, go for number 5, reg. It will open everything for you. You need the correlation coefficient, so you go for R number 3, press 3 and equal. It will give you what?
D.
Yeah. How much? A or D?
0.6.
D.
A or D?
D 0.6.
Thank you so much. Okay. Now, I think we use different data. Oh, no, yeah, different data, right? Do you have your calculator? This time, you are going to find what? Find the linear regression equation. So which one is the right one? Again, go for mode. Number 3, stats. Go for A plus BX. Now you will have 2 columns because you deactivate the 3rd column. Input your data one by one. After you finish, press AC and then choose shift and 1 and 1. And you have, yes, number 5, reg. In the reg, you have A, number 1. So press number 1 and press equal. So you will have A equal to what?
A equal 100.
100. Excellent. Now, no need to input your data again. Again, shift and 1, and then go for reg again, right? But this time you press number 2 because it will give you the slope B. So press 2 and press equal. So B will equal to what?
Minus 10.
Minus 10.
Minus 10. Perfect, right? So the correct answer is, yes, my equation should be A plus BX. Y equals, A is 100, so 100. B is minus 10, so minus 10x equal to Y. So where is Y equal to minus 10x and 100? The right answer is B. Perfect. Now, no need to use your calculator right now. Why? Because he's asking you What is the coefficient of determination? I know the coefficient of determination is r square, or r capital square if you like, right? So he gave me the r square over here. So no need to calculate anything, right? So the right answer is A. Okay. Now the same graph and asking me about what? Coefficient of non-determination. I know the coefficient of non-determination is 1 minus r square. 1 minus, he gave me r square over there. So 0.8454 equal to what?
Sí.
C, which is 0.1. If you would like to write it in percentage, it will be 15.46%, right? You multiply by 100 if you like it as a percentage, okay? Now, what is the meaning of this one? It means this percentage, a change in Y. What's Y? The number of units sold in Y results by X, results by the change on X, results by the change in X, right? This is the meaning of this percentage, right? Okay. Now, you have this graph and asking you about what? What is the slope of the linear regression? The slope is B. B is in front in X. So whatever bx plus a or a plus bx, whatever in front of X with the sign is the slope. So I have X here. So this is my B and should be, it is positive 0.623. So it is positive relation because it's going up as well, right? Now the right answer should be 0. Now you have the same shape, but it's asking you for what? What is the y-intercept? The y-intercept is A. Yes. Where is A? A next to X, without X for sure. So this is A, the y-intercept, right? Okay. What is the meaning of this one? It means y equal to this value when X equal to 0, right? Thank you so much.